By the start of the next decade, ARM could dethrone Intel as the face of computing as we know it. But how did we get to this point? Since 1978, Intel's golden child, the x86 lineup, has been the face of CPU architecture, powering everything from personal computers to data centers from the likes of Microsoft, IBM, Hewlett-Packard, Dell, and more. Because of this early dominance, it has become the foundation for most software we use for work, school, and play. Everything depended on it, and no one could escape it. Then Apple walked away.
We've created something wild. With a fire in its belly. This thing draws everything in, moving silently, night and day, into the deepest blacks and brightest lights. Its eye, razor sharp. Its sound, deafening. Pretty. Dangerous. So why would anyone give this beast more power?
If you were to say ARM would someday become the platform computers and desktops would eventually run on back in 2020, you would have been laughed out of the room. But we now live in a world where iPads rival MacBooks across all categories. While the tech industry has seen countless revolutions, few have been as shocking as Apple's switch to silicon, and as the company leads the charge, we are set to see familiar giants fall at the feet of innovative newcomers. In this video, we'll cover the start of Apple and Intel's friendship under Steve Jobs, the breaking point that led to their breakup, and Apple's rise to becoming the face of ARM. So, sit back and relax as we take a deep dive into the decisions behind the industry most never hear of, and remember to subscribe for more stories like these. But first, we have to go back to a time when American Idol played on everyone's TV, everyone and their dog had a Wii, and the PowerBook was Apple's hottest product. Welcome to 2005. Initially, PowerBooks, the precursors to today's MacBooks, had been powered by PowerPC chips, the result of a close partnership between Apple and IBM that had lasted for years, but began to show cracks when delays to the release of the PowerBook G5 worsened. The G5 was the fastest chip in the world for a relatively brief time as a 64-bit desktop processor. However, its performance fell below that of the G4 processor in performance per watt efficiency, making it easier for Intel chips to compete against PowerPC for the first time. Alongside Motorola, Apple and IBM were members of a broader landmark partnership known as the AIM Alliance. The focus of the alliance was on the development of the PowerPC chip as a computing platform for both hardware and software, best in Intel's Pentium series and comfortably seated among the most powerful on the market for its time. It was meant to be a mutually beneficial relationship for the three, and it was up until the early 2000s. The success of IBM's server and enterprise segment had brought in more profit for the company than producing chips for Apple did, and due to the conflicting change of priorities, the alliance began to crumble as the cost of scaling production had increased for Motorola, resulting in longer timelines for the release of the G5 and failed promises.
And yes, it's true. We are going to begin the transition from the PowerPC to Intel processors, and we are going to begin it for you now and for our customers next year. I think a lot of you would like a G5 in your PowerBook, and we haven't been able to deliver that to you yet. But these aren't even the most important reasons. The most important reasons are that as we look ahead, though we have great products right now, and we've got some great PowerPC products still yet to come, as we look ahead, we can envision some amazing products we want to build for you. And we don't know how to build them with the future PowerPC roadmap. And that's why we're going to do this. When we look at Intel, they've got great performance, yes. But they've got something else that's very important to us. Just as important as performance is power consumption. And the way we look at it is performance per watt. For 1 watt of power, how much performance do you get? And when we look at the future roadmaps projected out mid-2006 and beyond, what we see is the PowerPC gives us sort of 15 units of performance per watt. But the Intel roadmap in the future gives us 70.
At WWDC of 2005, Jobs announced Apple's new partnership with Intel, ending the AIM alliance. From there on, PowerBooks had been renamed to MacBooks, ditching power, timelines for new chips were shortened, and performance per watt efficiency increased. The new Intel chips also began getting rolled out in iMacs. The partnership proved to be one of the best investments Jobs could have made, with the MacBook Pro-Core Duo processor being nearly 5 times as powerful than the PowerBook G4. It was the end of an era. A decade-long partnership with IBM and Motorola had blown up, and in its place, a friendship with Intel blossomed.
We think there's too much compromising to get there. Too much compromising on thickness, too much compromising on less than a full-size display, less than a full-size keyboard, and we think you could put even more performance in one of these products. So, let's take a look at the thinness first. This is that Sony product. Again, one of the best in the field. 1.2 inches down to 0.8 inches. This is the MacBook Air. 0.76 inches down to an unprecedented 0.16 inches. Now, I want to point something out here. The thickest part of the MacBook Air is still thinner than the thinnest part of the TZ series. Okay? And so let me go ahead and show it to you now. This is it. Let me take it out here. This is the new MacBook Air, and you can get a feel for how thin it is. Yeah, there it is. There it is. All right. Amazing product here. Full-size keyboard, full-size display.
The years between 2006 and 2012 were Apple and Intel's honeymoon period. While MacBooks became a more competitive brand in the personal computer market, they brought developers around the world together to further grow Intel's x86 empire. And we even had Macs running Windows through Boot Camp, a utility still around today if you have a computer from this era. This was all built around Intel's TikTok production model. Not the social media app whose ownership is still questioned to this day, but a two-stage manufacturing cycle started in 2007, where 1 year Intel would release a CPU based on an already existing microarchitecture, the internal design of a processor, using a smaller manufacturing process. But in another year, called Stage 2, the company would release a CPU based on a new microarchitecture with that smaller manufacturer, if that makes any sense. Hence, it's called the TikTok model, because it alternates between these two stages. This model was adopted to ensure a consistent pattern across Intel's yearly releases. It began with the release of the 45nm Nehalem microarchitecture in 2008, a new design, and the 32nm Westmere microarchitecture in 2010, using the same Nehalem design. That's how you pronounce it. This cadence felt like clockwork, and with Apple's new partner being more consistent than IBM and Motorola ever could, it grew a sense of trust with Intel. Truly, it was the best of times, but then came the worst of times. Starting in 2013, Intel was slowly breaking away from its trusted TikTok cycle, until its official end in March of 2016. Within those 3 years, the quality of Apple's computers experienced a noticeable decline, with power efficiency and overheating becoming recurring issues. On top of this, the release of Intel's 10nm chip had been delayed multiple times between 2016 and 2019, and when it did come out, it did so in small, low-quality batches, damaging the company's reputation as a reliable manufacturer. Performance gains and improvements in battery life had barely changed in those years, and the blossoming partnership these two companies once had died. But despite all these problems, Apple looked inward, and back in 2010, Steve Jobs introduced the company's A-series chips for the iPhone 4 and first-generation iPad. The two devices, alongside the iPod and Apple TV, were faster, quieter, and more efficient than the MacBooks by magnitudes. They weren't using x86, but the ARM architecture. Nobody believed ARM could even come close to dethroning x86. After all, Intel's prize baby had been king for decades at that point, but Apple dared to defy that belief. With their relationship at a boiling point in 2020, Apple under Tim Cook pulled the trigger, one that would remain the face of ARM to this day. The company had a trick up its sleeve. For years of experience it had from the A-series by building its own chip in-house, and it had played its cards right. On November 17th of that year, the M1 debuted. It didn't come with a massive cooling system or the build of a one-trick pony. Instead, it was a system on a chip. A full package included CPU, GPU, RAM, and many other crucial components, but on one device. However, what you see is a game changer that challenged Intel's leadership in the chip-making industry, but that is only half the story. Most companies try to transition to building their own chips usually fail for three important reasons, the first being the cost. When it comes to manufacturing your own chips in-house, a common pitfall many companies run into is underestimating the cost of doing so, not only financially, but also in time and effort. Timelines for in-house production can very easily become decades. They require massive investments in research and development, which include hiring for specialized hardware knowledge, dealing with select manufacturers who tend to prioritize their highest paying customers, and the cost of building your own plant. These are all long-term investments, and unlike software, the best approach would be to start with something small, gradually building up to the release of your own technology instead of building it to a sudden launch. The next reason would be finding the expertise. Chip making is a very complicated process but might be the closest thing we have to magic. Nowadays, transistors tend to be around 1/1000th of a meter, nearly the diameter of an atom, and all the companies you see in the space, from Apple to Nvidia and Microsoft and Tesla, are all clients of the Taiwan Semiconductor Manufacturing Company.
Everything that in your phone, in your computers, it's the brains of everything that has a power switch and anything that needs compute.
In the heart of the desert, some of the country's most advanced chips are born, and it's no easy feat.
Making a wafer is the most complicated manufacturing process in the world. I can't imagine anything else more difficult than this.
Up to 4,000 precise steps, and just one slip.
You're done. You have to start from the beginning. Basically, these wafers cannot be used anymore.
What makes TSMC different? They don't design the chips, they build them, customized for clients. The magic happens inside the clean room, a tightly controlled environment where chips are created, tested, and perfected. It takes workers like Sterling to make sure what's promised is delivered. He's an EBO mask technician, essentially quality assurance.
What I'm doing is on EUV is basically an electric ultraviolet beam. That's EBO, electric ultraviolet beam. And I'm looking through this scope and I'm looking at all these different things. Again, trying to make sure that exactly how we have our pattern is how they have their map.
TSMC's first fab is up and running in Phoenix, making 4-nanometer chips, and they're just getting started, announcing earlier this year another $100 billion investment to ultimately have 6 fabs, a research and development center, and 2 advanced packaging facilities.
Taiwan Semiconductor Manufacturing Company, simply known as TSMC, is the world's largest semiconductor chip maker, and it has devoted decades to its craft. If you haven't heard of its tensions with China, then you will know that this much of a dependence on one company is dangerous in the long term. But the talent making up TSMC is extremely challenging to replicate in other parts of the world, particularly the US. The most valuable tech companies in the world simply do not have the capability to become self-reliant in chip making, and I don't see that changing in the next 5 years. And now the final reason, supply chains. With the complexity of semiconductor manufacturing comes the fragile global supply chain between clients and third parties, such as TSMC and Samsung, that spans materials, construction, and testing. This makes it very difficult to predict exactly when a specific chip will be fully ready, and it doesn't even account for factors such as tariffs, sanctions, geopolitical tensions, crises like the pandemic, and more. Even with all these challenges, Apple came through. But how? Experience from the A series chip was certainly a huge factor in the success of the M1, but the company's secret weapon came in the form of Rosetta 2, an emulator that would allow MacBooks run on Apple Silicon to run apps originally built for the Intel-based predecessors. Normally, when companies try to transition to their own chips, apps that were built for a previous platform break, which results in users complaining about the new device and developers hesitating about supporting it. Rosetta 2 would translate the Intel-based code ahead of time for a smoother experience, running in the background and supporting 64-bit applications. With it, users did not feel like they were exploring uncharted waters, but rather that they had upgraded. Because Apple Silicon is a system on a chip, it was more optimized for tasks such as video editing and 3D modeling compared to x86 systems. With the CPU, the brain of the chip, GPU, a 2.6 teraflop processor, and neural engine empowering machine learning, all sharing the same memory, issues such as latency and power inefficiency were mitigated. Then, the final piece snapped into place, Apple becoming the face of ARM as we know it. At first, Silicon was a spectacle, then it became a philosophy. The industry and developers quickly followed, with Microsoft rewriting Windows for ARM, Qualcomm and other manufacturers chasing Apple on its performance gains, and the perception of x86 as the default for serious work was shattered. Of course, x86 is still around today, being the chosen system for gaming PCs, enterprises, and more. Not because it is the best, but because it's hard to move away from. In the end, x86 wasn't just defeated, it was outgrown. Intel is still breaking a sweat over it, and the tech industry is still following ARM, and this brings me back to my thesis. If the trends we're seeing continue, and Apple Silicon consistently beats newly released x86 chips, by the start of the next decade, it could dethrone Intel as the face of computing. But if you want to know more about how Intel got to this point, watch my last video on its leadership loss in chip making. Thanks for watching, and I'll see you in the next one.